All right, we got a good one today. Doing systems of 3 equations. Just like doing systems of 2 equations, with a lot more steps. So get a piece of paper, get a calculator, because it's going to take some work. Okay. So our idea here, we start off with 3 different variables, and we want to simplify it down. So we want to take 3 variables and 3 equations. We want to simplify it to 2 variables and 2 equations, because that's what we've been doing. And then we can simplify it down to 1 variable and 1 equation, solve for that variable, and then work our way back up. Okay? So I'm just going to pick 2 of these equations. So I'm going to say these top 2. And I want to eliminate one of my variables. Unfortunately, for example, none of these really look like good candidates. But I want to get rid of z. So I'm not used to z. Last in, first out. Right? So let's get rid of z. What can I multiply by that will get rid of my z? So I have -5 and 2. So I can multiply this top equation by 2 and this bottom equation by 5. Okay. Again, it's not ideal, but that'll work. So I'm going to write it all out. So I've got 4x plus 8y minus 10z equals 36. And then on the bottom, -15x plus 25y plus 10z equals -135. Okay. Definitely check your work as you go. Take your time, because if you make one little mistake somewhere in your arithmetic, everything else is going to be messed up. So take your time. Don't rush through. So we add these together. So 4 and -15 is -11x. 8 plus 25 is 33y. The z's cancel out as intended. 36 minus 135 is -99. Okay. One thing you can do to help you out, if you get to this point, you can say, is there any way I can simplify this equation? Is there any common factor here? Hopefully you see, yes, I can get rid of an 11. So I can rewrite this equation as -x plus 3y equals -9. So all I did there was I just factored out an 11 just to simplify my equation. This one would also work, but the numbers get a little bit big, and the bigger the numbers are, the more difficult this can end up. Okay? All right, so that's one of our equations. Remember we said we need 2. So I'm going to come back to the original problem, and I'm going to pick 2 other equations I can work with. So I'm going to get rid of this and finish this part. So I'm going to keep it simple. I'm going to look at, make it blue. We'll look at these bottom 2 equations. You could also do first and third if that seemed like it would work better. But I usually go top 2 and then bottom 2. Okay, I need to get rid of the same variable. That's key. So since I got rid of z the first time, I need to get rid of z again. This one's a little bit easier though. I've got 2z and -z, so I just need to multiply this bottom one by 2. So I'm going to write these both out. So -3x plus 5y plus 2z equals -27. And then multiplying by 2, -10x plus 6y minus 2z equals -34. Okay. So I'm going to combine these 2 together. Make sure I got this right. Okay. -3x and -10x is -13x. 5y and 6y is 11y. The z's cancel out. 27 and 34 is 61. They're both negative. So it's going to be -61. Okay? So far, so good. So now I've got 2 equations, and they both have x and y. So right there, that's a system of 2 equations. So I'm going to take all that. I'm going to bring it over, or bring it down below, however you want to set this up. So I'm just going to copy these 2 equations. So -x plus 3y equals -9, and I have -13 13x plus 11y equals negative 61. Okay? So now this is what we need to solve for. I don't need to worry about all that stuff. This is my focus now. So I could go back to substitution, but we've been doing elimination. Might as well stick with it. 3 and 11, it's not so much we can do that, but we have negative 1 and negative 13, so I could multiply this top equation by 13, right? And so I'm going to bring that down here. So 13 times negative 1. No, wait a minute. I want to multiply that by negative. I want opposite sign, sorry. So negative 13 times negative 1 is going to give me positive 13x. Negative 13 times 3 is 39y. And negative 13 times negative 9 is, where did I write that down? 13. 1, I can't even read my handwriting. Hold on, let me grab a calculator. What did I say? 13 times 9. 117. Okay. Thank you, calculator. Those are both negative, so that's going to be positive. Okay, so all I did there was I just multiplied this whole red equation by negative 13. So now I can look at these two. I add them together, 13x, those cancel. 11y and 39y. Wait a minute. I missed a sign. Oh, this is supposed to be negative times positive. This is, I'm sorry. Trying to go quick and make mistakes. That's why we take our time. It's negative 13 times positive 3 is negative 39. All right. 11 minus 39 is negative 28y. 61 or 117 minus 61 is 56. Okay. So now I have one equation, one variable. So I can solve for y now. If I just divide both sides by negative 28, then we get y is negative 2. And we breathe a sigh of relief. That's the hard part. We did this, we're almost done. Okay? If you didn't get an integer value here, something's gone wrong. And that sucks, but you're gonna have to like go back through and see where you made a mistake because you missed something. All of these that you're gonna see today, most of them, if you're doing a separate problem or separate page of work, these will be integer values. So if you get decimal, something is gone wrong. Okay, so y equals negative 2. So I'm gonna take that answer, so I know this is right, and I'm gonna substitute it back into one of these equations up here. So I like this one in red. That one looks easier. So I have negative x plus 3 times negative 2 equals negative 9. And then we just solve for x. So 3 times negative 2 is negative 6. So I have negative x minus 6 equals negative 9. Add 6 to both sides. So I have negative x equals negative 3, which means x would have to equal positive 3. Okay, so now I've got two of my variables. I know x, I know y. So now I just need to go back. I gotta go all the way back to the beginning. So these original equations, pick one of those and then solve for z. So what did I say? X was 3. Okay, so if I go to this top equation here, okay, if I go to that top equation, substitute in the values for x and y. So 2 times, I keep forgetting what x was. 2 times 3 plus 4 times y was negative 2 minus 5z equals 8. Okay, and then I did this right. Oh my goodness. Oh my goodness. In my mouse. Oh, I almost had it. Hold on, bear with me. Bring these together. I just want to write it down. It's sort of, I ran out of screen space here. Like I said, it's a lot of work It's going to be worth it. It's going to be so satisfying when we have the right answer here. So 2 times 3 is 6. 4 times negative 2 is negative 8 minus 5z equals 18. Combine up my like terms, so 6 plus negative 8, negative 2 minus 5z equals 18, plus 2 to both sides. Just solving for z here. So negative 5z, 5s are looking like s's. Physically exhausted from solving this one problem. Divide both sides by negative 5. And we get z is negative 4. So there you go. Now we've got x, y, and z. We just need to put it all together in a final answer, which should be a coordinate. So we start with x. So x is 3, comma, negative 2, comma, negative 4. Piece of cake. We did it. You could go back. If we take 3, negative 2, negative 4, substitute it into any of those 3 equations, it should come out to a true statement. But I'm over this problem, so I'm trusting my math that says that is correct. So it just takes time. So start with 3 equations. Use elimination to get rid of one of the variables. And then you end up with a system of 2 equations, which you know how to do by now. And then you just solve that one. And then you will have your answer. Okay, what I wanted to do before I leave you, because for some reason on the paper it gives you one of these 3-dimensional grids, like it expects you to graph your answer, which is possibly the craziest thing I've seen in a while. But I want to give you an idea of what these graphs look like. So this is not the question we did, but it's a system of 3 equations. So you see them here, this is equation 1, equation 2, equation 3. So you can plot these. I don't know if you can even imagine what this plot would look like, but if you have 3 equations, the plot of that is an entire plane. So it's a 2-dimensional answer. So imagine that square extends forever in any direction. Okay? And so if you have 2 of these equations, they intersect on a line. See where these 2 squares sort of overlap each other. And when we add a third equation, a third equation adds a third plane, and 3 planes, assuming they're not parallel, will meet at exactly 1 point. And that is the point that we found. So all that work we did was to find the intersection of 3 separate planes. Which probably doesn't mean that much to you, but what does mean something to you is that correct answers get you points in your math class. So there you go. Good luck with the rest. Let me know if you need help.